Hello, Wellesley High School. Today we're going to talk about redox chemistry, or reduction and oxidation. We're going to start with assigning oxidation numbers. Oxidation numbers are very closely related to the charge on an element, and it's basically a way of keeping track of where the electrons are spending most of their time in a molecule. Okay, we're going to start with some easy ones. Basically, any time an element is by itself, its oxidation state is 0. Okay, so for our first two elements, Au, just by itself in its natural state, its oxidation state is 0. And then for our H2, the oxidation state is 0. Remember that hydrogen is one of our diatomic 7, and so H2 is a stable state for hydrogen, and so its charge is, or its oxidation state is 0. The next one is also very easy. If an element is by itself and has a charge, the oxidation number is the charge. Okay, so here we have Cl minus, so the oxidation state is -1. All right, the next ones are a little bit trickier because we have molecules. Basically, the thing to look for, if you look at these three molecules that we have, the sum of the oxidation numbers needs to equal the overall charge of the molecule. Okay, so for NH3 and CCl4, those are neutral molecules, and so the sum of all of the oxidation states needs to be 0. For NO3 minus, since the molecule has a -1 charge, all of the oxidation states need to add up to -1. Okay. There's a list of rules for oxidation states in your textbook. I recommend having that handy the first few times you try this, and then just start looking for patterns. Okay. So one of the rules in the book is that hydrogen is always +1. Okay, so if we start with NH3, each hydrogen is going to be +1, so that means the nitrogen is -3. Notice that I put +1 above the hydrogens, so I want to label the oxidation state of one of the elements, not the total. Okay, so here we have 3 +1s and 1 -3, and so overall the molecule is neutral, the oxidation states cancel out. Okay, let's try CCl4. Okay, Cl tends to make a -1 charge. Okay, so we're going to label Cl as having a -1 oxidation state, and so that means carbon has to be a +4 oxidation state. Okay, again, this molecule is neutral, and so we have 4 -1s and 1 +4, and the molecule has an overall neutral charge. Okay, NO3 minus is a little bit trickier. Okay, here we have to figure out which element to deal with first, and look at the overall charges. Okay. Oxygen has preference over nitrogen, so we're going to assign oxygen's oxidation state first, and oxygen likes to be in a -2 state. Okay, so if each oxygen is in a -2 state, and we have 3 of them, that means that overall oxygen is contributing a -6 to the molecule. Okay, we only want a -1. Okay, so nitrogen needs to be +5. Okay, if nitrogen is +5, each oxygen is -2. We get an overall charge of -1.